Suppose we have two circles that are tangent at this point. Then draw two lines that pass through the point of tangency of the two circles and that intersect the two circles at these 4 points. Now prove that this segment is parallel to this segment. Well, some people may say there exists a homotity centered at this point such that the small circle goes to the large circle, and this point would go to this point, and this point would go to this point, and therefore this segment would go under the homotity to this segment. But the image under homotity of a segment is another segment parallel to it, because homotity preserves the angles, or in other words, homotity preserves the shapes of the objects. So if this was a circle, it would preserve its shape and would stay a circle. If this was a triangle with certain angles, it would preserve its shape, and this would be a triangle with the same angles. And so this angle would be equal to this angle, or this side would be parallel to this side. People who say that would be 100% right. There is nothing wrong with using homotity. Just for the sake of this problem, let's try to prove it by using just angles. I'm gonna draw the tangent line to this circle at this point. Note that it is also a tangent line to the small circle, because the two circles are mutually tangent at this point. Now I'm gonna draw this angle, alpha, and I'm going to use the alternate segments theorem for this triangle and this circle. We'll know that this angle alpha corresponds to this arc of the small circle, which corresponds to this angle here, so this angle here is alpha. Now I'm going to use the alternate segments theorem for this triangle and the large circle. We know that this angle corresponds to this arc of the large circle, which corresponds to this angle. And therefore, this angle equals this angle from the alternate segments theorem. And now that this angle is alpha and this angle is alpha, we can conclude that this line is parallel to this line. Note that this property is also true for externally tangent circles such as these two. We know that if this is a straight line and this is a straight line and they intersect at the point of tangency, then this line is parallel to this line. Why? Well, consider a homotity with center this point that transforms this circle into this circle. The homotity will be with negative coefficient. Therefore, this point would go to this point, and this point would go to this point under the homotity. And so this segment will transform into this segment, which means that the two segments are parallel because homotity always preserves shapes and thus angles and thus parallel lines. It would be nice to come back to this picture and prove that if we have that this line is parallel to this line, then the circumcircle of this triangle is tangent to the circumcircle of this triangle at this point. Well, suppose these are the two circumcircles, and now draw the tangent lines to each circle at this point. Now assuming that this line is tangent to the larger circle, and this line is tangent to the smaller circle, we can again use the alternate segments theorem to prove that this angle equals alpha. We'll see that this angle is alpha, and so this arc corresponds to angle of alpha. And so this angle here, with respect to the tangent line to the small circle, would also be alpha. Similarly, since this angle is alpha, it corresponds to this arc of the larger circle, and so this angle here, with respect to the tangent line to the larger circle, equals alpha. Therefore, the angle between the two lines equals alpha minus alpha, or 0 degrees, and therefore the two lines coincide. And now we have a line and a point on the line, and two circles that are tangent to this line at this point. So both circles are tangent to the line at the same point. Therefore, they are tangent to one another. This is the optional problem. We have two circles that are tangent to one another at this point, and then we take 2 points on the smaller circle and we connect them with the point of tangency with these red segments, and then we connect the points themselves, and then this line intersects the larger circle at these 2 points. And then we connect these 2 points with the original tangency point, and then we need to prove that this angle here equals this angle here. And here's the solution. Let's continue the two red lines until they intersect the larger circle at these 2 points. A couple minutes ago, we proved that this segment is parallel to this segment, because the two red lines come from the point of tangency of the two circles. Notice that because of this cyclic quadrilateral, we have that this angle corresponds to this arc, and so equals this angle. And from this cyclic quadrilateral, we know that this angle corresponds to this arc, and so it equals this angle. But now from the two parallel lines, it follows that this angle equals this angle, and therefore this arc is the same as this arc.